Alright, what's going on, everybody? This video we're going to look at Newton's method. And basically what it is you're solving an equation, and the equation, you can't really solve it using things you learned. It's a difficult equation to solve. So we can use Newton's method to solve it. Now, some of the equations that we solve, yeah, you're going to be able to solve it, but it's just for, letting you know, okay, this is how we use Newton's method. Now, we'll do an example where we have an equation that's difficult to solve using algebra, and we'll use Newton's method on it. So, you can see in the first example, sure, you can solve this right here, quadratic formula, okay, or completing the square. We're going to apply Newton's method to it. So Newton's method, we've got x of n plus 1 is equal to x of n minus f of x of n divided by f prime x of n. So what we're doing is, when you're using Newton's method, you're making an initial guess, okay? You're making a guess here for this x of n, all right? And we call that x of 1. And what we do is we take our initial guess and we plug it into this formula here, and that gives us our x of n plus 1. And we can keep doing iterations of this and get it to where our approximation is, it's pretty close to what the answer is. And you'll see that when we work some examples. But let's go ahead and get started. But before we do, there are some instances where Newton's method would fail. So for instance, if you made your initial guess, say like you made an initial guess, say like in this, for instance here, 2, okay? And you go to plug the 2 into here, and when you plug it into the derivative, you get 0, okay? That would fail. All right, or if you make an initial guess that's, not a very good guess, your initial guess, you want to get it to where it's kind of close to the answer. And, for the most part, I have a feeling your teacher is going to tell you the initial guess, because I'm sure they don't want to grade papers where everybody's making different initial guesses. So they'll probably tell you your initial guess. All right, so let's go ahead and get started. So it says, starting with x of 1 equals 2, find the third approximation, x3, to the root of the equation x squared minus 2x minus 5. All right, now on this example, I'm going to write everything out, all the details and everything, and then on the rest of the examples, we're going to work them, but I'm not going to put all the details like I do in this first example. All right. All right, so we've got f of x is equal to x squared minus 2x minus 5. This is our function right here. And we have f prime of x is equal to 2x minus 2. All right, so let's just go ahead and write Newton's method here. X of n plus 1 is equal to x of n minus f of x of n over f prime x of n. All right, so let's see what we've got here. So we've got our initial guess, x1 is equal to 2. So in this case, n is 1, okay? N is 1. So if we plug the 1 in here for n, that's going to give us x of 1 plus 1 is equal to x of 1 minus f of x sub 1 over f prime x of 1. Okay, so remember, I told you I'm going to show all the details on this problem, and I'm not going to do all of this on the next ones. Okay, so I just want to do it on one problem so you can see everything. All right, So we've got x of 2 is equal to 2 minus f of 2 over f prime of 2, which is equal to 2 minus 2 squared minus 2 times 2 minus 5 over 2 times 2 minus 2. Okay, so all I did, the f of 2 and f prime of 2, I just evaluated the function and the derivative at 2. And when we punch all of that into our calculator, we end up with 2.1. All right, so that's x of 2, x of 2. But remember, they want us to find x of 3. All right, so we've got x of 2. So now we've got x of 2 plus 1. See, now I've got n as 2. So I'm going to plug the 2 in for n right here. And so that's going to be 2.1. All right, because look, remember, right now I'm doing n equals 2. So this is 2 plus 1. This is x of 2. Well, what's x of 2? It's 2.1. All right, and then x of 2, that is 2.1. So that's minus f of x2 over f prime x2. And so that's going to give us x3 is equal to 2.1 minus, and that's going to be 2.1 squared minus 2 times 2.1 minus 5 over 2.1, over 2 times 2.1 minus 2. And that is going to give us 2.0946. All right, and there's your solution. So that gives us one of our solutions. But we know what? There's probably two solutions here. We've got a quadratic equation, but Newton's method is we're making that first initial guess, so that's going to give us one of our solutions. We would have to do this again and make another initial guess closer to the other solution to get that other one. All right. So, like I said, on this problem, no, it's not going to be, it wouldn't be good to use Newton's method on this problem because we can use quadratic formula. But the whole idea of this is for you to learn how to do Newton's method. All right. And so this right here would be one of the solutions. Now, how accurate is it? Well, if you want to test the accuracy of it, you could solve this using quadratic formula and, take one of the solutions and see, that solution that's closest to this one and see how close it is. All right. So, and actually, it turns out that this solution here is accurate to within 4 decimal places. All right. So you can see we just found the third iteration. We found x of 3, and that got us pretty close to the solution. All right, let's look at the next example. Use Newton's method to find the 6th root of 2 correct to 8 decimal places. All right, so how in the world do we do that? Well, how would we do the 6th root of 2 using Newton's method? Well, first we need what? We need a function, don't we? We need a function. And once again, let's just x of n plus 1 equals x of n minus f of x of n over f prime x of n. Let's just write the formula down. So for our function, we would have what? X to the 6th whoop, x to the 6 minus 2 equals 0. That would be our equation, wouldn't it? Because think about it, if you solve this, you get x to the 6 equal 2, x equal the 6th root of 2. And that's what we're looking for. So all I did, I just, you can just work backwards to get your equation. All right, so now we have f of x is equal to x to the 6 minus 2, and f prime of x is equal to 6x to the 5th. All right, now we need to make an initial guess, don't we? We need to make an initial guess. And notice in this problem, they don't give us an initial guess like they did in the previous problem. Okay? So for this one, we have to come up with it on our own. Now there's ways that you can do this. You can get a graph of it, like you'll see in, I think it's the next problem we work, where we're gonna graph it and find our initial guess that way. But this one, just use some common sense. Okay, what's the square root of 2? It's 1 point something, right? We know it's not below 1. It has to be above 1, right? Well, what's the cube root of 2, the 4th root, the 5th root, the 6th root of 2? It's right around 1, isn't it? It's close to 1. It's not below 1. It's not above 2. It's right there around 1. So I'm going to make my initial guess to be x of 1 equals 1. All right? Now, like I said, in the problems that I work here, I'm not going to write this step in. I'm just going to go straight to this. Okay? All right. So we have x of 2 is equal to x of 1 minus f of x1 over f prime x1, which is 1 minus, now let's see, that's going to be what, 1 to the 6th minus 2 over 6 times 1 to the 5th. And that gives us 1.1 Okay, so we get that. Now, how many decimal places do we need to take this out to when we're doing our answer? Well, we need to go out 8 decimal places because it says we want this correct to 8 decimal places. All right, so there's x2. Well, we've got to find it. We've got to do another iteration because, well, we don't really know right now how close the solution is because we only have one number here. So if I do x3, that's going to be x2 minus f of x2 over f prime x2, which is 1.1 Right, and yes, and look, when you're plugging all this stuff in, make sure you write all the decimal places. Okay, write all the decimal places. All right, so this is going to give us 1.12644,368. All right, so are we accurate to within 8 decimal places? No, because the first decimal place matches, but the second doesn't. All right, so we've got to do another iteration. So let's do x4, which is x3 minus f of x3 over f prime x3. And that's going to be 1.1264436 minus 1. Oh, wait a minute. And this right here should be to the 6th. Okay, I forgot to put the exponent. So that's 1.1264436 to the 6 minus 2 over 6 times 1.1264436 to the 5th. And so x4, that is going to give us 1.12249,707. And you can see here the first 2 decimal places match, but the rest don't, so we have to keep going. So I need to find x5. That's going to be x4 minus f of x4 over f prime x4. Alright, so I plugged all that in, and for x5 I'm going to get 1.12246,205. And you know, you can see we're getting closer. We have what? 1, 2, 3. We have the first 4 decimal places match up. So I need to go again. All right, so I need to find x6. So that's x5 minus f of x5 over f prime of x5. And that is equal to, all right, so this is equal to 1.12246,205. And you can see here all 8 decimal places match. And so this is our answer. Okay. Now, you know, let's just see here if we actually put this into our calculator, what we would get. So when I plug this into my calculator, we get 1.122462048. 2048. So you can see, let's see, 1, 2, 3, 4, 5, 6, 7. There's 8 decimal places. So if you take that and you round that up, if you round it to 8 decimal places, that would match that exactly. So you can see how accurate this is, okay, when we're doing it. All right, let's take a look. Last example. All right. So it says find correct to 6 decimal places the root of the equation cosine x equal x. All right, so let's get our equation. Let's get everything on one side. So we got cosine x minus x equals 0, just moving the x over. And so I get f of x is equal to cosine x minus x, and f prime of x is equal to negative sine x minus 1. All right, so we have to make our initial guess. Now, this one, how are you going to make the initial guess here? Yeah, in the previous example, that wasn't difficult to make that initial guess, the 6th root of 2. We knew it was right around 1. But this one, well, I wouldn't have a clue of what the answer would be, would you? So on this one, we could graph it. We could graph cosine x. We can graph cosine x, and we can graph x. So I'm going to graph y equal cosine x, and I'm going to graph y equals x on the same coordinate system and see where they intersect. And I've done that already with some software. And by the way, this software right here that I'm using, it's called GeoGebra. Okay? It's the best free graphing software out there. check it out. You can install it on your computer, or you can use the online version of it. But it's really good. So you can see the green graph, that's cosine x. This black graph here, that's y equals x. And we can see that they intersect right here. You see that? And yes, we could, in here we could enter a point. We could put a point in here where they intersect. And you can see they intersect at an x value of about 0.74. Well, let's say we don't do that, and with this, you can adjust these decimals. You can adjust it where it carries it out to more decimal places. But what we're looking at is, see, they intersect here, okay? So they intersect close to 1. So I'm going to make an initial guess of 1. All right? So let's see how this goes. All right. So I'm going to make my initial guess to be x1 equals 1. And so now we will see what we've got here. So that's going to be x2 is equal to x1. I'm going to leave out, so what I'm going to leave out here is I'm going to leave out, right, no, I tell you, I'll put it in there, since you're learning how to do this. Let's just go ahead and write it out. So that's going to be x1 minus f of x1 over f prime x1, which that is going to be, let's see, that's going to be 1 minus, that's going to be cosine 1 minus 1 over, and that's going to be negative sine 1 minus 1. Okay, that's going to give us our x sub 2. And so that, when we punch that into our calculator, we end up with 0.75036387. All right. And so now let's go to x3, and I'm gonna go ahead and write them all out. I'm gonna pause the video, and we'll pick back up after I write them out. All right, so I've plugged all these in, and I'm just writing down the last one. And so, you can take a screenshot of that, with your phone, if you're watching on your phone, or take a picture of it with your phone of all that. But, that's all it is. And you can see we match right here. And, in the graph, it gave us that answer of 0.74. And see, if we round this to 2 decimal places, we get 0.74. Now, the one thing that's very important that you make sure of when you're doing this with trig functions, you may have plugged this into your calculator and you're saying, well, I'm not getting that. Well, make sure your calculator is in radians, okay? You're not going to work with degrees anymore. You're going to be working with radians from now on. So, but yeah, that's Newton's method. Does it take some time to do it? Yeah. But, how long would it take you to solve this equation without Newton's method? And I know, you just graph it on your calculator or in this in graphing software or something, and there it instantly gives you the answer. Okay? But, you got to learn how to do this stuff. All right? So, I hope this video helped. Check out my other videos. Give me a like, share, and subscribe. Thanks for watching, and I'll see you later.